Hello everyone and welcome to another discussion about functions. Today we're going to be talking about quadratic functions, and more specifically we're going to talk about their graphical representation, parabolas. So we're really talking about quadratic functions, so I'll put like quad fun here beside parabola. And what we want to do is we want to describe a parabola using their key features. One thing to think about is that everything has key features that you can use to describe it. So, for example, if you wanted to talk about a person, you might talk about their height or their weight, or what their clothes are, or what their favorite food is, or where they live, or try to describe things about them. And there's some key features that'll really help you narrow down who you're talking about. And that's what we want to do. We want to talk about which parabola are we really talking about, and what are some of the key features that you can use to do that. Now, we did an exploration in class that helped us identify these things, but just to recap some of them. So some things that you might want to know about parabolas, and it's much simpler than with people because parabolas are just simpler shapes than people are. So if we wanted to describe them, some of the things we could talk about is the vertex. So the vertex is this point right here on the parabola. So I'll identify that one with red, and I'll put a red underline under there. And the vertex in this case is -1, -8. Remembering that the x value and the y value go in alphabetical order when you talk about a point. The next point we could talk about, let's make this nice green color. Let's talk about the x-intercepts. So in this case, there's two x-intercepts, and we have our x-intercepts being equal to -5 and 3. Remembering that the first value here is what we're interested in for both of these because we're talking about the x values. Another thing that might be of interest, and let's use this purple color for this, is the y-intercept. So we've got the y-intercept where it crosses the y-axis is equal to -7.5. Okay, what else could we talk about with this? Well, this parabola doesn't look like this, it looks like this. So let's describe that as opens up. So it opens up, and you might want to describe how wide it is. So you can see here that this is the original machine that we talked about. This one there, the dashed black line, is y equals x squared, just the simple squaring machine. Okay, and this looks a bit wider than that, and so we could say wider than y equals x squared. Something else that's important, you see this blue line that I have in the middle, the dashed blue line, it's this color. We call that the axis of symmetry. If you folded the parabola in half, then the axis of symmetry would be the fold line so that both sides of the parabola line up. So the axis of symmetry, just call it axis of sym. We'll put a colon because this we use an equation for, and we say what the x value is all the way along that vertical line. So this is a special line where the x value stays the same. It always stays at -1 there, and the y value can change along that line. So we just say x equals -1 for that. Now, another thing that we talk about a lot when we talk about key features are transformations. Transformations just tell you how you went from y equals x squared to this new parabola. So how did we change it? Well, we shifted it. We took this point, we went down here, and then over. So we can say there was a vertical, or up-down, vertical translation, which is a fancy word for shift. Down 8. And there was a horizontal. I'm just going to be lazy and write that. And I'm just going to use this word again by using ditto signs. So horizontal translation, left 1. Well, what else is there? It's wider, right? So we call that a compression when it's wider by a factor of, and let's take a look at some points and how they changed. So this one here, we went right 2 and up 4. Here, when we go right 2, we go up 2. So it was like compressed in half. So compressed by a factor of 1/2. And that's what you call transformations. They talk about how to change y equals x squared into this new one. Okay, I know that looks like a bit of a mess, but the key here is to know what the features are, how to identify them from the graph, and just this terminology for transformations. Okay, let's look at another one. So this one here I don't have on the original one, but that's okay. We won't do transformations on this one, but you could if we had enough room to put y equals x squared. It would make it easier. So notice here we don't have any x-intercepts. It never crosses through. So if I was asked to identify the x-intercepts, maybe I'll do that first. I'll just say not applicable. There are none or does not exist. All of those I would take, no problem. Okay, the y-intercept we can identify is equal to, down here, at minus 23. And the vertex is this turning point, right? Where we stop going in one direction, we start going the other. So we're not going up anymore, we're coming down, right? So that turning point is the vertex. We're going to call that 3 minus 5 in this case. And we have an axis of symmetry. Of x equals 3. And you may have noticed that these numbers always be the same. Okay, and I can't tell if it's wider or not because I don't have the equation for this and I don't have the original graph. So let's leave that off. And just keep in mind that that's an important thing that we'll have to check. So those are just a couple of quick examples helping us identify the features for a quadratic function or a parabola.